Hi guys, we were talking about trigonometric ratios under chapter 8, which is trigonometry in the NCERT book. So till now we have seen a few concepts. The first one was, in a right angled triangle, if the angle is constant, say this one, it's theta, so whatever be the measure of the sides, the ratios always remain constant corresponding to this particular angle, and those ratios are known as trigonometric ratios. We saw 6 different ratios for a right angle triangle. For the angle theta, we saw sine theta was equal to perpendicular by hypotenuse. We saw cos theta, which was base by hypotenuse. Then we saw tan theta. Tan theta was sine theta by cos theta, or perpendicular by base. Then we saw the inverses of these ratios. Cosec theta was 1 by sine theta, which was hypotenuse by perpendicular. Sec theta was 1 by cos theta, that is hypotenuse by base, while cot theta was 1 by tan theta, or base by perpendicular. Now if you remember, we had spoken about what perpendicular, base and hypotenuse were for a right angle triangle. Say this is the right angle triangle, the longest side is the hypotenuse always, while the side opposite to the angle in consideration is the perpendicular, or the opposite side, and the side which is adjacent to the angle in consideration is the base. We had also seen that if one of these 6 ratios is given to us, then we can find out all the other 5 ratios. Correct? Now these were the concepts that we had spoken about in the previous videos. Now let's look at a few examples. Now this is the question that is given to us. It says that if in a right angle triangle, triangle ABC, right angled at B, tan A is given as 1, then we have to verify that the value of 2 sine A into cos A is equal to 1. Now let's see how do we go about this. Now the first step always is to draw the right angle triangle. Let's draw a right angle triangle. This is triangle ABC, say. Now we know that it is right angled at B, so this will be B, and it's given that tan A, this is angle A, so tan A is equal to 1. We have to verify that 2 into sine A into cos A is equal to 1. So what do we need for this? We need the value of sine A and we need the value of cos A. So we have to find out the value of sine A and the value of cos A. We also know that if we are given one ratio, we can find out all the other ratios. So tan A is given to us. How do we go about finding sine A and cos A? Now ABC is the triangle where tan for angle A is given to us. So for this angle, which will be the perpendicular? Perpendicular is always the opposite side. So this is the perpendicular and the adjacent side is the base, and hypotenuse is always the longest side. And we know that tan of angle A can be written as perpendicular by base, or in this case it can be written as BC by AB. Correct? Because BC is a perpendicular and AB is the base. If BC by AB is given as 1, from here we can say that BC is equal to AB, or the perpendicular and base are of the same length. Now let us assume that BC and AB are K, some positive real number. So can we find out the value of H? Yes. By the Pythagoras theorem, we have hypotenuse square is equal to base square plus perpendicular square, or AC square is equal to AB square plus BC square. We know the value of AB and BC. We've assumed it to be K. So AC square would come out to be K square plus K square, which is 2K square. And from this I can find out AC, or the hypotenuse, is equal to under root 2 times K. Now when we know the value of this was K, this was K, and this is root 2 times K. Can we find out sine A and cos A now? Yes, of course. So sine A is nothing but perpendicular by hypotenuse, which is K by root 2K. So K by root 2K, K gets cancelled, and we are left with sine A equal to 1 by root 2. Similarly, we can find out the value of cos A, which is nothing but base by hypotenuse. We know base was K as we had assumed, and hypotenuse came out to be root 2 times K. And again, cos A is also equal to 1 by root 2. Now this does not end the question for us, because we had to verify what would 2 sine A into cos A be. So in the left hand side we have 2 into sine A, whose value is 1 by root 2, into cos A, whose value is 1 by root 2 again, and this gives us 2 into 1 by 2, because root 2 times root 2 is 2, and this gives us 1, which was also equal to the right hand side. Hence we have verified this given relation for this given triangle. Now let's look at another example. Now here the question given to us is, in a triangle OPQ, which is right angled at P, we are given OP as 7 centimeters and OQ minus PQ as 1 centimeter. We are supposed to find out all the trigonometric ratios. So again, the first step, if you remember, is drawing the triangle OPQ. This is right angled at P, so this is P. So let's call this Q and let's call this O. So we have triangle OPQ, right angled at P. We are given that OP, or say this side, is 7 centimeters and OQ minus PQ is 1 centimeter. Now it's clear that OQ is the hypotenuse, this one, the longest side. From the given relation of OQ minus PQ equal to 1 centimeter, let's find out the value of PQ in terms of OQ, or the other way around. So we have OQ as 1 plus PQ, and by the Pythagoras theorem we know that OQ square is equal to PQ square plus OP square. If we substitute this value of OQ here, we would have 1 plus PQ whole square is equal to PQ square plus OP was 7 centimeters. So this would be 7 square. We can further solve it to get 1 plus 2 into 1 into PQ plus PQ square equal to PQ square plus 49. I have just expanded 1 plus PQ whole square as 1 plus 2 into PQ plus PQ square. So PQ square and PQ square gets cancelled from both sides. What we are left with is 1 plus 2 times PQ is equal to 49, or 2 times PQ equal to 49 minus 1, which means PQ is equal to 48 by 2, or 24 centimeters. This gives us, from the earlier relationship here, OQ equals PQ plus 1, and PQ was 24, so we have 24 plus 1 or 25 centimeters. So we have the values of OQ and PQ here. PQ is 24 centimeters and OQ is 25 centimeters. So we can find out all the ratios now because we have the sides. Now let's find out quickly what the ratios were. I'm just drawing a rough figure here so that we have, this was Q, this was O, this was P. We had PO as 7 centimeters. We found PQ as 24 centimeters and OQ was 25 centimeters. So let's consider angle Q first. For angle Q, what is the perpendicular? The opposite side, that is OP, is the perpendicular. And what is the base? The adjacent side, that is PQ. PQ is the base. So for angle Q, we will find out all the 6 ratios, that is sine of Q, which is perpendicular by hypotenuse, or 7 by 25. Then cos of Q is base by hypotenuse, which is PQ by OQ, that is 24 by 25. And tan Q would be sin Q by cos Q, which gives us 7 by 24. And the others would be cosec Q, which would be 25 by 7. Sec Q would be 25 by 24. And cot Q would be 24 by 7. Similarly, we can find out for angle O. So for angle O, the perpendicular would be the opposite side, that is QP would be the perpendicular and PO would be the base. So you can find out all the other ratios similarly.